Glider 9-2 Soaring Weather. We're exploring the fascinating world of thunderstorms and how they can impact glider flying. Understanding the risks associated with these powerful weather phenomena is essential for every pilot. Imagine an atmosphere perfect for thermal soaring, suddenly transforming into towering cumulonimbus clouds, the unmistakable sign of thunderstorms. Now, let's break down the stages of a typical thunderstorm: cumulus, mature, and dissipating. As the storm progresses, so do its hazards: turbulence, strong updrafts, downdrafts, hail, icing, reduced visibility, lightning, and even tornadoes. Mother Nature can be quite formidable. Keep an eye out for those towering cumulus clouds, signaling the mature stage and bringing potential microburst and strong surface winds. Even if a storm seems to be dissipating, hazards can still exist. Hail, a common thunderstorm feature, can impact both metal and composite gliders. Icing is a concern within the cloud, affecting performance. Reduced visibility due to precipitation and low ceilings beneath the storm add more challenges. Lightning is unpredictable, and tornadoes are a serious threat spawned by severe thunderstorms. When thunderstorm activity looms, stay vigilant for early signs and consider landing and securing your glider. Now, we're exploring the fascinating world of slope soaring, a technique that harnesses the power of wind encountering elevated terrain. So, what do you need for an exhilarating slope soaring experience? Just two things: elevated terrain and, of course, wind. Imagine the wind encountering a ridge or hill. It can be deflected horizontally, vertically, or a combination of both, creating slope lift. Not every hill or ridge is ideal for slope soaring. Isolated hills won't cut it, but a longer ridge with a windward face of about a mile or more can produce the sought-after slope lift. Now, the height and length of the ridge matter. Slope lift can extend up to 2 or 3 times the ridge height, but the pilot may only climb to the ridge height. So, the higher the ridge above the adjacent valley, the higher you can soar. Aim for a minimum ridge height of 500 to 1,000 feet above the valley. But wait, there's more to it. The windward slope needs to be steep enough, ideally around 1 to 4. Too shallow won't create enough vertical wind, and too steep can lead to turbulent eddies. Always assess the slope and wind conditions for a safe experience. Be cautious of downdrafts on the lee side of the ridge, which can be strong and make upwind penetration impossible. Also, be mindful of the three-dimensional effects of oblique winds and bowls, as they can impact slope lift. We're exploring now the captivating world of wave soaring, a thrilling adventure for glider pilots. So, let's dive in and understand the magic behind riding atmospheric waves. In the skies, wind and stable air come together to create waves, and when near mountains or ridges, these waves can offer an exhilarating soaring experience. But first, let's distinguish wave soaring from slope soaring. Unlike slope soaring on the upwind side, wave soaring takes place on the downwind side, producing a unique and dynamic ride. Imagine stable air encountering a mountain, initiating a mesmerizing sequence of vertical displacement and oscillation. This sets off a series of waves downstream, forming a smooth flow in the wind, but beneath lies a low-level turbulent zone known as the rotor. This turbulence adds a challenging yet exciting dimension to the soaring experience. Clouds become our companions in this adventure, painting the sky with cap clouds, rotor clouds, and lenticular clouds, creating a beautiful tapestry of nature's canvas. The presence and types of clouds depend on the moisture content at different levels, adding variability to each soaring expedition. Successful wave soaring requires suitable terrain, with uniform ridges and the right topography profile enhancing wave amplitude. As we navigate the dynamic skies, diurnal effects play a role, with lee waves disappearing as thermals intensify during the day and re-emerging as thermals settle toward evening. Challenges like interference patterns in wave formations highlight the complexity of soaring, requiring pilots to master the art of reading the atmospheric symphony. For an ideal slope soaring experience, you'll want wind speeds of 10 to 15 knots, nearly perpendicular to the ridge. Wind directions slightly off perpendicular can still provide slope lift. Remember, the area of best lift varies with height. Below the ridge crest, it's closer to the ridge, and above, it's further upwind. Keep an eye on stability and wind conditions. In stable air, slope lift can be smooth, but in unstable air, thermals may mix in. This combination can make slope soaring challenging, especially for beginners. Moisture matters too. If rising air cools and becomes moist, a cap cloud may form, limiting usable height. So, always stay aware of changing conditions and have an alternative plan. We're going to dive into the fascinating world of convergence lift. Picture this. When easterly and westerly winds collide, air is pushed upward. It doesn't always happen head-on. Wherever air piles up, we get convergence and rising air. Now, let's talk about a common example near coastal areas, the sea breeze front. Inland areas heat up, creating lower pressure, drawing in cooler sea air. This convergence line can lead to consistent lift or even trigger thunderstorms. Sea air often has a higher dew point, forming a curtain cloud marking the area of strongest lift. The sea breeze front's characteristics, like turbulence and strength, depend on factors such as the temperature difference, synoptic wind flow, and inland heating. Convergence can also occur around mountains or ridges, forming lines of lift. In mountainous terrain, convergence can form along the top of a ridgeline. Drier air on one side meets moist air on the other, creating lift conditions. Toward evening, cool katabatic winds flowing down slopes can converge with air in the valley, forming weak lift or triggering the last thermal of the day. So, whether you're in flat or mountainous terrain, be on the lookout for lines or zones of lift caused by convergence. Now, let's talk about a crucial aspect of flight planning, obtaining reliable weather information. Now, pilots are fortunate to have various outlets for weather reports and forecasts to ensure safe flights. For visual flight rules, VFR, flights, it's mandatory to gather weather info if you're departing the airport vicinity, but it's always a good idea to stay informed for any flight. So, where do we get our pre-flight weather information? We've got automated flight service stations, AFSS, National Weather Service, NWS, telephone briefers, direct user access terminal system, DUATs, and the internet. Commercial vendors also provide custom services. Now, onto pre-flight weather briefing. To get one, provide essential details like type of flight, visual flight rules or instrument flight rules, aircraft registration, departure and destination airports, route, altitude, estimated time of departure, ETD, and estimated time en route, ETE. Airports are fixed base operators, FBOs, often post current reports and forecasts on bulletin boards. Remember, weather briefers don't predict weather. They interpret reports and forecasts for your specific flight. You can request standard, abbreviated, soaring, or outlook briefings. Moving on to weather-related information, the internet is a valuable resource, especially aviation-focused sites. Just be cautious. Verify timeliness and sources for accuracy. We've got the graphic weather charts, surface analysis, radar summary, weather depiction, and more. These charts give us a snapshot of observed atmospheric conditions. Moving on to the winds and temperatures aloft forecast, issued twice a day. This one helps us anticipate winds and temperatures at different altitudes. Soaring pilots, take note that levels below 18,000 feet use local altimeter settings. For soaring, the stability panel is key. A positive lifted index means stable air, while negatives suggest potential soaring conditions. The K-index helps gauge the likelihood of air mass thunderstorms. Remember, when using these charts for soaring flight, the relative stability of an air mass tells us about the clouds and turbulence we might encounter. If you click like and subscribe and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.